Good evening, students. Now we shall continue the probability. In that probability, axiomatic approach to probability topic. Already we know the definition of axiomatic approach and the three important points regarding the satisfying the axioms of the axiomatic approach. After that, with a coin tossing experiment of the example and also the assignment of the valid approach of the probability, then probability of an event with an example, probabilities of equally likely outcomes with an example and formula. And now we shall begin with the probability of the event A or B. Probability of the event A or B. Welcome. In the probability of event A or B, let us find the probability of the event A or B. That means A union B. A union B. Yes, am I right? Let A is equals to HHT, HTH, THH, and the set B is equals to HTH, THH, HHH, be the two events associated with tossing a coin thrice. Already you know, when a coin is tossed thrice, the total number of the outcomes are 8. But here, A defines the outcomes having two heads appear. Two heads appear. In the set B defines at least two heads appear. But set A and B are the two events associated with tossing a coin thrice. From this, it is clear that A union B equals to HHT, HTH, THH, HHH. How do you find A union B from the sets? First, we should write all the elements belongs to the set of A. All the elements belongs to set of A. Then, from the set B, we have to select which is not repeated from the set A. Means the new element only we have to associate in the set of A union B. That means A union B equals to HHT, HTH, THH and HHH. Next, then probability of A union B for the above set is denoted P of HHT. Individually we have to find the probability of each outcome plus P of HTH plus P of THH plus P of HHH. Here 1 upon 8 because total number of the sample space of the outcomes becomes 8. Hence for 1 this is 1 upon 8 plus 1 upon 8 plus 1 upon 8 plus 1 upon 8, totally LCM 8, then 4 by 8 which is equals to 1 by 2. This is known to be as the equally likely outcomes. This is known to be as the equally likely outcomes. Then, and also we have to find probability of set A, P of HHT plus P of HTH plus P of THH, because three outcomes belongs to the set A. Then total number of the probability of A set is equals to 3 by 8. Similarly, here in the set B, there are three outcomes from the set B. Therefore, we have to find the probability of B. Therefore, individually, P of HTH plus P of THH plus probability of HHH, here 3 by 8 is the probability of the set B, and probability of set A also 3 by 8. By adding probability of A plus probability of B is equals to 3 by 8 plus 3 by 8, which gives 6 by 8. It is clear that probability of A union B is not equals to probability of A plus probability of B. Already we have studied earlier regarding this. But one thing, the points HTH and THH are common to both set A and B. The points HTH and THH are the common to both the sets A and B. Therefore, in the computation of the probability A plus probability B are the probabilities of the points HTH and THH. First, you should keep it in your mind, because the points HTH means the outcome HTH and THH are common to the set of the A as well as set of B according to his notation. So for that purpose, in the computation of the probability of A plus probability of the B, the total probabilities of the points HTH and THH are not countable here. So the elements A intersection B are included twice. Do you know? The elements A intersection B are included twice. Thus, to get the probability of P of A union B, we have to subtract the probabilities of the sample space points in A intersection B from P of A plus P of B. Means whatever we noted, two elements eliminated, HTH and THH are eliminated from the set. Hence, the probability of A union B equals to probability of A plus probability of B minus summation of probability of omega I, where omega I means A intersection B. That means P of A intersection B. This is one point. And therefore, P of A union B equals to P of A plus P of B minus P of A intersection B. This implies A minus B union of A intersection B union of B minus A. All this becomes same. Do you know? This becomes the same to of this point. Then A union B equals to A union of B minus A. A union of B minus A is nothing but equals to A union B, where A and B minus A are mutually exclusive. Sir, why we should write like this? A union B equals to A union of B minus A, because this element and B minus A is one kind of the element. Both A and B minus A are the two elements which are mutually exclusive. Because while we are going towards with to find the A union B, then which is equals to the null set. Yes, then, and B is equals to A intersection B, and B equals to A intersection B union of B minus A, where A intersection B and B minus A are mutually exclusive events. Here, this and this are mutually exclusive event. In the above notation, A union B equals to A union of B minus A, where A and B minus A are the mutually exclusive event. Let us see how the A union B can be executed by using the law, by using the axiom third of the probability, by using the third law of axiom of probability, axiomatic probability. We get here, by using the law, we get here P of A union B is equals to P of A plus P of B minus A, note as equation 1. Yes? And P of B equals to P of A intersection B plus P of B minus A. This is the equation 2. Do you know what is the first equation and what is the second equation? Keep it in your mind. So, from subtracting the second equation from the first, which gives P of, means second equation must be subtracted from the first equation, which gives P of A union B minus P of B is equals to P of A minus P of A intersection B, or P of A union B equals to P of A plus P of B minus P of A intersection B. I recall your memory in the set chapter, the Venn diagram formula, N of A union B is equals to N of A plus N of B minus N of A intersection B. Comparing the formula here with the probability of the set A union B, which gives probability of A plus probability of B minus probability of A intersection B. The above result can further be verified by observing the Venn diagram. John Venn, who introduced the diagram regarding the union intersection of the sets from two groups. Yes, here you observe this figure, Venn diagram. U intersection B and A minus B are the elements belongs to the set A. Elements belongs to the set A. And here A intersection B and B minus A are both elements belongs to the set B. To find the elements which are belongs to the intersection, then whatever both circles are intersect at the point, 2 points, which the portion which shows the A intersection B elements. A intersection B elements means P of A intersection B is the common. Here we should write the common elements in both the circles are intersects to each other. Do you know? That means we clarified that A and B are mutually exclusive events, then which gives the result of A intersection B is equals to null set. Therefore, probability of A intersection B is equals to probability of the null set, which gives 0. ಜಾನ್ ವೆನ್ನನ ಒಂದು ನಕ್ಷೆಯ ಮೇರೆಗೆ ಎರಡು ಗಣಗಳನ್ನು ನಾನು ನಿರ್ದೇಶಿಸಿದಾಗ ಮೊದಲನೇ ಗಣದಲ್ಲಿ ಗಣವನ್ನು ಎ ಅಂತ ಹೆಸರಿಸ್ತೀನಿ, ಎರಡನೇ ಗಣವನ್ನು ಬಿ ಅಂತ ಹೆಸರಿಸ್ತೀವಿ. ಮೊದಲನೇ ಗಣದಲ್ಲಿ ಗಣಾಂಶಗಳು ಎ ಮೈನಸ್ ಬಿ ಮತ್ತು ಎ ಇಂಟರ್ಸೆಕ್ಷನ್ ಬಿಗಳಾಗಿವೆ. ಎರಡನೇ ಗಣದಲ್ಲಿ ಗಣಾಂಶಗಳು ಬಿ ಮೈನಸ್ ಎ ಮತ್ತು ಎ ಇಂಟರ್ಸೆಕ್ಷನ್ ಬಿಗಳಾಗಿವೆ. ಈ ಎರಡೂ ಗಣಗಳಲ್ಲಿ ಒಂದು ಛೇದನ ಗಣವನ್ನು ನಾವು ಕಂಡುಹಿಡಿದಾಗ ಈ ಎರಡೂ ಗಣಗಳು ಈ ಎರಡೂ ಸರ್ಕಲ್ಗಳು ಅಂದರೆ ಇವು ಎರಡೂ ಸರ್ಕಲ್ಗಳು ಎಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗ್ತವೋ ಅಲ್ಲಿ ಛೇದನ ಗಣವನ್ನು ತೋರಿಸ್ತಿರ್ತೀವಿ. ಅದು ಎ ಇಂಟರ್ಸೆಕ್ಷನ್ ಬಿ ಈಸ್ ದ ಪೋರ್ಷನ್ ಡೆಸಿಗ್ನೇಟೆಡ್ both the circles intersect each other. Yes, ಇದರಿಂದ ನಾವು thus we have to justify that for the mutually exclusive events A and B, we have to find the P of means probability of A union B is equals to probability of A and probability of plus probability of B, which is found together by axiom number 3 of the probability of axiomatic approach. Yes, it is clear that probability of A union B equals to probability of A plus probability of B. By using the laws of axiomatic approach of the probability of third. Axioms andru onde, laws andru. Dear students, next we shall continue the last one, probability of event not A. Already we know in the axiomatic approach very important concepts of the 3 points. One is the probability of an event A, is probability of an event. Second one, the probabilities of equally likely outcomes. Third one, the probabilities of event A or B. And the last point is probability of event not A. Very carefully, already all the types of the events A or B, A and B, A but not B, and not A, already we studied earlier in the definition concepts of the probabilities. But in axiomatic, this is the last unit. Up to this, the entire concept of the theory part is over. Now we shall begin the probability of event not A. Only thing, here we will get a 2-mark question. Prove that probability of not A is equals to 1 minus probability of A. How do you prove this? So let us see. You know very well all the 4 types of the probability events. Then let S be the sample space. A dash and A are mutually exclusive. What is A and what is A dash already you know. A dash is the complement of the A and exhaustive events here. A intersection A dash is equals to null set and A union A dash is equals to capital S. S be the sample space because A union of A dash, complement of A and A, which gives the universal set. Here instead of universal set, he has taken as a sample space. What we should prove? To prove that probability of A dash is equals to 1 minus probability of A. Very, very important concept for 2 mark only. Proof. We know that A intersection A dash is equals to null set and A union of A dash is equals to S. Here probability of A union A dash is equals to probability of S because A union of A dash which gives the sample space. P of A plus P of A dash, P of A plus P of A dash is equals to 1. Yes? Or probability of A dash is equals to 1 minus probability of A. You take probability of A as this side, which becomes minus. P of A dash means it is not A. P of A dash is the complement of A means hence it is not A. Probability of not A is equals to 1 minus probability of A. Thus proved. Yes. Is it understood? If you are having any difficulty, you call to my number. I will justify your answers with details. Students, this is the end of the theory part from your probability chapter. In the next class, we shall begin the problems based on the axiomatic approach of probability from the 16.3 exercise. So now I am going to wind up your class. Thank you. All the best. Okay. Good night.